All right, my beautiful Math 2 people, we got lesson 3.2.3, expanding the trig table. All right, so let's see where we're going to start with this. Okay, we'll start right here. So it says on your piece of paper, draw the slope triangle for a 45-degree angle. All right, so we're just going to sketch it out. So 45 degrees. Let's do our slope triangle right here. We know that in a 45-degree angle, that this would be an isosceles right triangle because both of these would be the same. So if this side were 2, this side would also be 2. And so what we've seen is that when we have a slope angle of 45 degrees, or an angle of 45 degrees, the slope, these two sides are the same. So the change in y is equal to the change in x. So the slope, in this case, is 2 over 2, or just 1. So at a 45-degree angle, we get a slope of 1. Part A says, what if we were to change this angle to a 55-degree angle? Well, if we did that, we'd add 10 degrees on. I'm just estimating. Let's say that 10 degrees more would be right there. I don't know if it is, but whatever. We're just pretending. So let's say that that angle right there is 55 degrees. Well, what we see here is the x has not changed, but the y has increased over here. So since we've opened up this angle and made it bigger, this side that's made from that angle has now gotten larger. So what's getting longer? The change in y is getting longer. Change in y is definitely bigger at this point. So would that slope be bigger than 1 or less than 1? So for a 55-degree angle, should we get an angle that's bigger, or a slope that's bigger than 1 or less than 1? Well, we've increased the size of y. Let's say that our increase, I'm not saying it is, but let's just say that was 1 more or something like that. Well, what we would have now is 3 over 2. Well, 3 over 2 is bigger than 1. So what we would expect is if we have an angle larger than 45 degrees, the slope should be over 1, which would also mean that if we have an angle less than 45 degrees, that our slope would be less than 1. So it'd be like a fraction like 0.2, 0.3, 0.4, something like that. So we would expect here this is bigger than 1. And in fact, the slope for a 55-degree angle is 1.429. That's actually pretty close to what I wrote here. This is 1.5. I was just guessing. I hadn't even read ahead. All right, so find the value of x. What is the value of x in this case? That would probably be the change up here, how much we changed it by. So if these were 1s instead, I probably should have done that as 1s. The value of x, this change over here, oh no, it's talking about this one. Man, I should read ahead. It's early, so sorry. Anyways, so our slope triangle should be 55 degrees. So we know that the slope should be 1.429. That's 1.429 over 1, so as a fraction. So what's the change in y? The change in y is 8 over here. And what's the change in x? The change in x is x, we don't know it. So since the slope for 55 degrees is 1.429, then 8 over x should be equal to that. And now we can just do cross products. 1.429 x equals 8 times 1, 8. So x would be 8 divided by 1.429. I really should read ahead when I'm doing these problems. Oh dear. All right, calculators out. So 8 divided by 1.429 ends up being 5.5983250. Let's just round that. Let's call it 5.6-ish. So on my calculator, I got a big old long number. I'm going to just round that to approximately 5.6. All right, on previous lessons, we have already looked at other slopes. We obviously know that if the angle has 0, then it's not going to have any slope at all, so we can skip that one. But on that very first lesson where we started looking at it, we saw that an 11-degree angle gives us a slope of 1/5. And we saw that when we took the complement to 11, so the complement to 11 is 79 degrees. And here's what we saw with 79 degrees. We saw that it was 79 degrees. We saw that it was the reciprocal, 5/1. So up here we've got 11. Down here we've got 11, and that's 1/5. So the complement to 11 is 79. So they add up to 90 degrees. So we saw that these ones would be reciprocals. Now remember, if this is 11, this part here is 79. And so its slope triangle is 5/1 instead, because you kind of have to flip the triangle around. Okay, so we've got all these different things that we've messed with in previous lessons, and they're all here on this trig table graphic organizer. So we've got all these. So a slope triangle of 18. If it's 18 degrees, this one is 1/3. So this would be 1, this would be 3. 22 degrees. The change in y would be 2. The change in x would be 5. And that was from the first lesson too. So these were all from the first lesson. Now remember, complements are the reciprocal. So what is the complement of 18? The complement of 18 would be 72. And what we see here is that its slope triangle would be 3/1, because I'm kind of flipping that around here. So now I'm looking at it in this direction. So here's 72. So now the change in y is 3, and the change in x is 1. Now let's go down to 72, and don't you know it, it's 3/1. So anytime we have a complement, the slope triangle is going to be the reciprocal. So it's going to be flipped. The numerator and the denominator will switch places. So 11 degrees and 79 degrees are complements. And we notice here, we got 5/1, 1/5 up there. 18 degrees and 72 degrees. These are complements, and those are flipped around. 22 degrees and 68 degrees. These are complements, and look at their slope triangles. They're flipped. All right, so now we're going to use all this information to solve these problems. All right, so part A. I've got 70 degrees right here, and this is y/10 for the slope. So I want to know what is the slope ratio or this for a 70-degree angle. Well, on this chart here, it says that the slope ratio for a 70-degree angle should be 13.737/5 or 2.747. Let's just use the 2.747. So we know that it is 2.747, and we're going to put that over 1. And now we can just use cross products. 1 times y is y, and 2.747 times 10 is 27.47. Or we get about 27.5. I don't know why I'm writing sideways like that. Again, it's pretty early. Sorry. All right, next one. On this one, we've got theta. I don't know how many degrees that is, but I know that its slope is 50/6. Now 50/6, we should reduce that. It looks like 2 would go into both of these. So this would be 25/3. All right, so I'm going to look on my table and see if I can find a slope triangle of 25/3. If I find it, then that's how many degrees that angle would be. All right, so looking around, 25/3, there it is right there. 25/3, 50/60, that is an 83-degree angle. So, since I know that slope triangle, the slope ratios only go with one specific angle, I know this angle has to be 83. There's no other angle that's going to give us this slope ratio. Every angle has its own slope ratio. So now I know that theta must be 83 degrees. Next one, we've got theta again, and we know its slope ratio is 10/1. Okay, go back to the chart. Let's look for something that has 10/1. Here it is right here, 10/1. The only angle that has a slope ratio of 10/1 is 84 degrees. So now I know that theta must be 84 degrees. Next one, slope ratio of 8 degrees. So this should be equal to 20/x. All right, let's look up on our table and find out 8 degrees. What is its slope ratio? For 8 degrees, the slope ratio is 26/185, or we can just use this approximation of 0.141. Let's just use the approximation of 0.141. So we're going to say 0.141/1. And now we can use cross products. So x times that is 0.141x, and then 1 times 20 equals 20. To solve for x, I will now divide 20 by 0.141. Calculator time. 20 divided by 0.141. Comes out to, you can't even see that, there it is, 141.8. We'll just round it to 0.8. So this is approximately 141.8. And this actually kind of makes sense because here I've got a really small angle. So that means the y is going to be a lot smaller than the change in x. So it would make sense that this number should be a lot bigger. Remember, when your angles are small, your slope ratios are small. So that means your y is less than your x. When the angles are big, your slope ratio has the y bigger than the x. So on this one, we can see that 2.747, that was bigger than the x one. So that goes back to up here. When it's 45 degrees, the slope ratio is 1. If you go over 45 degrees, your y should be bigger than your x. When you go under 45 degrees, your x should be bigger than your y. All right, next one, we got theta. This must be a trick question. 0/14. You can't have 0. So 0/14 is just 0. So that means, of course, if you're changing y as 0, there's no angle there. Theta must be 0 degrees. That was kind of dumb. All right, last two. All right, we've got a slope ratio of 89, and that's going to be y/2. So we take out our chart. 89 degrees says that it's 5,729/100, or 57.29. Let's just use the 57.29. All right, so I'm going to say it's equal to 57.29/1. Cross products, I get y is equal to 2 times 57.9. I'd say that's about 100 and, let's just use my calculator because it's way too early. Times 2, 114.58. So y is equal to 114.58. I should have been able to do that without a calculator. All right, so we just did cross products. 1 times y is y. 57.29 times 2, 114.8. Last problem. Now we've got a slope ratio of 90 degrees. Wait a second. 90 degrees? 90? That's not possible. You can't do that. If this angle's 90 and this angle's 90, that's 180 degrees in the triangle. We can't have a 90 degree angle right here. That would mean this angle is 0 degrees. And that's not possible. That's not a triangle. That's 0 degrees. Okay, so we've learned something important here. Our angles have to be between 0 degrees and 90 degrees. You can't have angles equal to 90 degrees. You can't have angles equal to 0 degrees because that's not a triangle. So all of our angles have to be between 0 and 90 degrees. Otherwise, this is just not going to work. It's not a real triangle because if this is a 90 degree angle, you can't have another 90 degree angle in there because it won't be a triangle. So that's not possible. All right, that's all we got. That was an easy one. See you later. Math hard. Bye-bye. How do I stop this?